What keeps your feet firmly planted on the ground, preventing you from drifting off into the vast expanse above? What is this constant yet often unnoticed companion that dictates so much of our daily existence? Gravity, the invisible force that shapes, molds, and dictates the very fabric of reality as we perceive it. It's a fundamental interaction, a universal phenomenon that's been studied and pondered over for centuries. Our world, holding everything in its place, from the smallest grain of sand to the tallest mountain range. It dictates the flow of rivers, the formation of landscapes, and the very air we breathe. Our solar system, guiding the planets in their eternal dance around the sun, maintaining the delicate balance that allows life to flourish on Earth. And the universe itself. It's the architect of cosmic structures, the sculptor of galaxies, and the unseen hand that governs the grandest scales of existence. It's why you don't float away into the inky blackness of space, a constant reminder of our connection to this planet. Why the moon orbits Earth, in a celestial ballet that has captivated humanity for millennia, influencing our tides and inspiring countless myths and legends. And why Earth orbits the sun, a journey of 365 days that dictates our seasons and the rhythm of life on our planet. Gravity acts on everything, everywhere, all the time, a relentless and pervasive force that never sleeps. Every object with mass pulls on every other object, a subtle but constant interaction that binds the universe together. But the Earth's immense mass makes its pull the one we notice most, the dominant gravitational force in our daily lives. This force gives us weight, a measure of the Earth's gravitational pull on our bodies. Makes things fall, a simple demonstration of gravity's power that we witness countless times every day, and holds our world together, preventing it from disintegrating into a cloud of dust and gas. We'll explore how Newton and Einstein, two of the greatest minds in history, revolutionized our understanding of gravity, shifting our perspective from a simple force to a fundamental property of space and time. From falling apples, the legendary inspiration for Newton's law of universal gravitation, to warped space and time, Einstein's revolutionary concept that gravity is not a force, but a curvature in the fabric of the universe. Gravity orchestrates the dance of planets, guiding them in their elliptical paths around stars, creating stable and predictable solar systems, shapes galaxies, pulling together billions of stars, gas and dust into swirling cosmic islands, and creates the conditions for life, by providing the stability and structure necessary for planets to form and evolve. It's both simple and complex, a force described by elegant equations, a force we experience every moment, yet rarely consider its profound implications. Get ready to see the world in a new way, to appreciate the subtle yet powerful influence of gravity on everything around you. As we unpack the science behind this universal force, exploring its mysteries and marveling at its elegance. Gravity isn't just a topic in physics, it's a fundamental aspect of reality. It's the glue of the universe, holding together everything from atoms to galaxies. By the end, you'll have a new appreciation, a deeper understanding of the force that shapes our lives and the cosmos. For the unseen power that governs every moment of your life, a constant companion that shapes our world and our understanding of the universe. Imagine the universe not as empty space but as a giant, invisible, stretchy sheet, space-time. It's a fabric woven from space and time, a concept that might seem strange at first, but it's key to understanding gravity. Think of it as the ultimate stage upon which all cosmic events unfold. Now place a heavy bowling ball right in the center of it. This represents a massive object like our sun, or any star for that matter. The bowling ball creates a deep indentation, a significant warp in the fabric of space-time. The heavier the object, the deeper the dent it makes. Now, roll a marble nearby. Instead of traveling in a straight line, the marble curves around the dent created by the bowling ball. This is precisely how planets orbit stars. They're not being pulled, but rather, they're following the curves in space-time created by the star's mass. This was Einstein's revolutionary insight. Gravity isn't a mysterious force pulling at a distance, as Newton described, but the result of mass actually curving and warping the very fabric of space-time around it. It's a fundamental shift in how we perceive the universe. The sun's immense mass warps space-time considerably, creating a large gravity well in its vicinity, and Earth, instead of being pulled towards the sun, simply follows the curve in space-time, orbiting in what appears to be a perpetual fall around our star. The moon orbits Earth for the very same reason. Earth warps space-time around it, and the moon dutifully follows that curve, just on a smaller scale, a more intimate cosmic dance. Even astronauts in the International Space Station aren't experiencing zero gravity. They're constantly in freefall, perpetually falling around Earth, which is why they experience the sensation of weightlessness. They are constantly accelerating towards Earth, but also moving forward fast enough that they keep missing the ground. In essence, gravity, according to Einstein, is the geometry of the universe itself, not some magical, invisible tether pulling objects together. This profound perspective elegantly explains not only planetary orbits but also the phenomenon of ocean tides, and even the seemingly bizarre behavior of light bending as it passes near massive objects, a phenomenon known as gravitational lensing. So the next time you observe a satellite in orbit or gaze upon the graceful dance of planets, remember that it's simply an object faithfully following the curves and contours of space-time, guided by the mass of the celestial body it orbits. In a way, gravity is the ultimate cosmic roller coaster, a thrilling ride through the dips and curves of space-time. Everything in the universe is always falling, constantly accelerating through space-time. It's just that sometimes, instead of crashing, we're fortunate enough to be falling in circles, caught in the graceful embrace of an orbit. And that's the profound and elegant beauty of Einstein's universe, a universe where gravity is not a force, but a shape. Before Einstein, Isaac Newton gave us the first mathematical law of gravity. Inspired by a falling apple, Newton realized the same force that pulls apples down keeps the moon in orbit. His law, every object attracts every other, with a force stronger for bigger masses and weaker with distance. Newton's equations let us predict planetary orbits, tides, and more, tools still used today for satellites and space missions. Newton's insight connected the fall of an apple to the motion of the moon, forever changing our view of the cosmos. For centuries, Newton's law of universal gravitation reigned supreme, providing a framework for understanding how objects attract each other. It was a monumental achievement, explaining everything from the fall of an apple to the orbits of planets. But as scientific instruments became more precise, cracks began to appear in Newton's elegant theory. Certain phenomena, like the peculiar orbit of Mercury, stubbornly defied explanation. The planet's path around the sun exhibited a slight yet persistent anomaly that Newton's law couldn't fully account for, like Mercury's odd orbit. The stage was set for a revolution in physics, and at the heart of this revolution was a brilliant mind. Enter Einstein, who dared to challenge the established order. He reimagined gravity, not as a force pulling objects together, but as something far more profound, the curvature of space-time, not a force but a consequence of mass and energy, warping the very fabric of the universe. Massive objects warp space-time, creating what we perceive as gravity. The more massive the object, the greater the distortion it creates. And smaller ones, like planets or even light, follow the straightest path, known as a geodesic, in this curved landscape. It's like rolling a marble on a warped surface. The marble follows the curves and contours of the surface, guided by the geometry of space. This revolutionary idea had startling consequences. Even light, which has no mass, bends near massive bodies following the curves in space-time. This prediction was put to the test during a 1919 solar eclipse when astronomers observed starlight bending around the sun precisely as Einstein had predicted, as confirmed during a 1919 solar eclipse. With his theory of general relativity, Einstein not only explained gravity in a new way, but he also resolved the mystery of Mercury's orbit. Einstein's theory explained Mercury's wobble, providing a complete and accurate description of its motion. But the implications of general relativity didn't stop there. The theory also predicted phenomena like gravitational time dilation, where time slows down in stronger gravitational fields, and the existence of gravitational waves, ripples in spacetime caused by accelerating massive objects. General relativity transformed our understanding. It was a paradigm shift that revolutionized physics and astronomy. Gravity is geometry, not just attraction. It's the very fabric of spacetime dictating how objects move and interact. The sun doesn't pull Earth, it doesn't exert a mysterious force across empty space. It shapes the spacetime Earth moves through, guiding our planet along its orbital path. This new view was confirmed by experiments and observations, solidifying general relativity as one of the most successful theories in physics. Einstein's groundbreaking work catapulted him to international fame, making Einstein a scientific superstar. General relativity also revealed that time runs slower in stronger gravity, a phenomenon that has been experimentally verified with atomic clocks, and that ripples, gravitational waves, travel through spacetime, carrying information about the most cataclysmic events in the universe. These predictions, once science fiction, relegated to the realm of theoretical speculation, are now proven facts, cornerstones of our understanding of the cosmos. Einstein's vision reshaped our understanding of the universe, forever changing the way we perceive gravity, space, and time. Gravity is not just a force, it's not merely an attraction between objects. It's the shape of reality itself, the underlying geometry that governs the motion of everything from planets to galaxies. And that shape is still being explored today, with scientists pushing the boundaries of our knowledge and seeking to unravel the deepest mysteries of the universe. Gravity isn't just cosmic, it's with us every moment. It pulls you out of bed, pours your coffee, and shapes every step you take. Athletes, from basketball players to divers, master gravity's pull in every move. Our buildings, bridges, and even chairs are designed to resist gravity's relentless tug. Plumbing, roller coasters, and countless machines rely on gravity to work. Our bodies evolve to fight gravity, bones and muscles grow strong to support us, and our hearts pump blood upward. In space, astronauts lose bone and muscle because gravity's challenge is gone. We are creatures shaped by Earth's gravity, perfectly adapted to its pull. Gravity isn't just around us, it's part of who we are. Gravity choreographs the grand ballet of the cosmos. The sun's gravity anchors the solar system, keeping planets, asteroids, and comets in orbit. Without gravity, everything would drift into space. Gravity formed the sun and planets from a cloud of gas and dust, igniting stars and building worlds. On a larger scale, gravity shapes galaxies, vast cities of stars orbiting a common center, often a supermassive black hole. Spiral arms, star clusters, and galactic collisions are all gravity's handiwork. Galaxies themselves group into clusters bound by gravity's reach. The Milky Way and Andromeda are on a collision course, destined to merge in billions of years. Gravity weaves the cosmic web, organizing matter across unimaginable distances. Every star, planet, and galaxy moves to gravity's rhythm. The universe's structure is gravity's masterpiece. From solar systems to superclusters, gravity is the architect. The dance never ends. Mass and weight aren't the same. Mass is how much matter you have. Weight is gravity's pull on that mass. Your mass stays the same everywhere, but your weight changes with gravity. On the moon, you'd weigh 1/6 as much as on Earth, but your mass is unchanged. Astronauts leap higher on the moon because gravity's pull is weaker, not because they're stronger. Mass creates gravity. Weight is what you feel standing on a planet. What you actually feel is the ground pushing back, called the normal force. In freefall, like in orbit or a falling elevator, you feel weightless because nothing pushes back. Gravity is always there, but weight is the sensation of resisting its pull. Understanding this difference explains why we feel heavy, light, or even weightless. Gravity shapes our experience, but it's the normal force we feel every day. Gravity is essential for life on Earth. It formed our planet and keeps our atmosphere wrapped around us, protecting and nourishing life. Without gravity, Earth couldn't hold air, water, or maintain a stable climate. Gravity drives the water cycle. Rain falls, rivers flow, and water collects, sustaining ecosystems. The sun's gravity keeps Earth in a stable orbit, providing steady warmth and light. Our planet's position in the Goldilocks zone is a result of gravity's perfect balance. Life depends on gravity's constant, gentle pull. Gravity is the silent guardian that makes Earth habitable. Our quest to understand gravity has transformed science and our view of the universe. Gravity is the cosmic glue, binding planets, stars, and galaxies in a vast web. Newton gave us the math, Einstein revealed the geometry. Gravity shapes our world, our bodies, and the conditions for life. Yet mysteries remain: dark matter, dark energy, and the true nature of gravity itself. The search continues, pushing science to new frontiers. Gravity is both familiar and deeply mysterious, a force that invites us to keep exploring. The universe's story is written in gravity's invisible script. If you like this type of factual information, please like, subscribe, and share. Thank you.